Hi, my name is Robert Marder. I'm a graphics and multimedia engineer at Collabora, and I'm here to give a short presentation about video offloading on the Wayland Linux desktop, its current state and challenges. And what I'll be talking about is what is it and why do I think it matters? I give a short refresher about the involved hardware and software components to give you a rough understanding what we're talking about. Then shortly go into recent and current development, and finally speak about some challenges and give an outlook on what to expect soon. So what is it? We're talking basically just about efficient video playback on desktops, and this has been possible for a long time on embedded devices, but more recently we've been finally be able to get that to the desktop as well. And the reason why I think this matters and is important is there are a lot of quite obvious good reasons, I think, like better performance, better battery, longer battery time, etc., etc. However, the part that I find most interesting is the community aspect, because by having these technologies being used by the Linux community on their setups, daily driving them, has a lot of advantages regarding testing. Like if you have a big community using a feature, you get lots and lots of testing on different setups. And at the same time, there's a high incentive for people to, when things don't work, to look into the code, work on it, improve it, make it work on their setups. And therefore, we are directly training new engineers who might then be not only be very competent in this area, but also be highly motivated because they are working on something they're using themselves. And that's something very useful on the strategic side, I think. It certainly worked for myself. So buffer sharing. In short, on Linux we use DMA buffers or DMA-buff. That's a framework to share buffers between hardware and also different subsystems on Linux. And if we focus on hardware decoders, GPU, and display engine, which are the important parts here for zero copy video playback, then to give you a rough idea, like in a simple world, setups would look either like this. You have a dedicated GPU or device which has the renderer, the decoder, and the display engine all sitting on one device and using the same VRAM. And for efficient playback, you mainly need to make sure that things don't go to the CPU or the system RAM and back. And otherwise, you just need to ensure to not have too many copies in RAM or something. And on SoCs, you might, in an optimal world again, have an even simpler case where really everything, all involved components, can access the same memory. You can use DMA buffs just freely to pass them around between the different components, and they never actually have to get copied. However, in the real world, you can imagine it's a little bit more complicated. The most intuitive part probably is MultiGPUs, where you can imagine if you use a decoder on one device and then want to render on it on a different device, or put it on a display connected to a different device, you usually have a way to directly copy between the devices, but you need to ensure that actually they both understand the format in use and the memory tiling, etc., etc. And there's all kinds of limitations on that. But also in the simple cases of just having one dedicated GPU, it's already the case. It's often already the case that, for example, the display engine does not actually have access to all memory or all kinds of features that you use on different memory tiling, etc. So let's say your display engine only has access to a certain amount of video memory. Then you need to ensure you should better not always allocate your buffers in that part of the memory because it will quickly be full. But instead, you need to carefully decide when to allocate buffers in that memory and when not. Similar restrictions apply in many real-world SoCs. A typical example here is that the display engine, again, is a different component, actually, and doesn't, first of all, only has access to a certain amount of memory and also maybe doesn't have an I/O MMU, cannot use virtual memory. And this you need to allocate in a very specific way to make things work. And on the software side, what you usually have is you use some kind of multimedia framework like GStreamer, for example, which then has decoder elements which talk to the kernel, which then talks to the actual hardware decoder. Then this multimedia framework needs to interact with the toolkit that you will most likely be using, for example, GTK4, and then both sides need to negotiate about which formats, etc. Again, they support and need to pass through all this information. And the toolkit, again, will then usually talk to the Wayland compositor. This is the Wayland part in all of this. And allow pass buffers through. And that compositor in the end will then again finally talk back to the kernel and to to the display engine. So the takeaway from this is we need a lot of info to make good decisions about buffers, where to allocate them, by whom, and pass all relevant info through so all these components can work well together in the generic environment. A major step forward here has been explicit modifiers, which by now have been plumbed through to a lot of components, and this made things much, much easier and better. However, we're still not done yet. We will probably need even more APIs, notably about DMA heaps. I will come back to that later. So what have been recent and current developments? I'm sorry, I only have very limited time, so I can only go into a few examples here. However, what I found quite noteworthy is especially the GStreamer 1.24 release, which finally introduced a modifier, a new API, which is DMA specific and has support for explicit modifiers. again, this has made things much better on a lot of on many sides. Noteworthy is this is an ongoing effort, and quite a few elements don't support that yet, however, are being in the process of being converted. Noteworthy here is that the VA API and default to stateless elements already support that explicit modifiers. However, default to stateful does not yet, and that will be required to enable zero copy. This is actively being worked on, by the way, and we have for a long time having had working proof of concept, which will hopefully find its way into upstream soon. On the compositor side, there's been a lot of movement over the last year. MultiGPU finally landed support for video formats like NV12, which is commonly used for which is commonly the format used by video decoders in version 45 about a year ago, and K1 6.0 that was released earlier this year did the same, which is great because that means now on both major desktops we have support for video formats in Wayland. On the toolkit side, Gtk 4.14 was a big release with coming with support to offload buffers to Wayland subsurfaces, which then can be used by the compositor to offload to the display engine, for example. That was also earlier this year. And more recently, now with the Gnome 47 release, the Gtk for Paintable sync, which is the recommended way to interface between GStreamer and GTK4, got a lot, also got support for all of this. So now the whole pipeline from GStreamer up to the compositor is in place, and we'll be shipping apps that support this by default. More on this later. Another part worth noting on the browser side is Chromium, which has support for a lot of this already, which was mainly developed for the Chrome OS effort, which, as you may know, recently got halted. However, there's ongoing work to bring this finally, to make this work on the generic Wayland backend. And I hope we will see that soon. So what are the main challenges? When we're dealing with the three common graphics APIs, DesktopGL unfortunately doesn't have native support for video formats at all. It is possible to use custom shaders in some situations, though, to still, in many situations, though. GLES does have native support. However, there are limitations regarding the color formats, the exact color representation, which is not guaranteed by the API. And all of this will get much better with Vulkan once it really the more toolkits and apps get ported to Vulkan, the easier all of this will get. The other big development is, of course, color management and HDR in Wayland. There has been a lot of progress lately on this. Both Gnome and Kwin ship with preview versions of the protocol, which unfortunately hasn't landed yet. However, there's good chances that by the time the next big releases come in spring, we'll finally have support for that. Demos. I wanted to show some videos to give you some better idea about all of this. However, I don't have enough time for that. So instead, you can just install Showtime, for example, from FlatHub or from, if you're on a recent distribution, just from your package manager, and try it out and see how well that works for you. So thank you. Thanks for your time. I hope there's some time left for some questions. And by the way, we are hiring. Thank you.